In this video, you will learn how to insert a new element at the specified position of an array. I will demonstrate how to insert elements into an array with this project that you can program with me. But if you haven't done so yet, first go watch lesson 17.1 to 17.11 to learn more about arrays. When our program starts, the list box displays March to December. We will refresh the list box every time a new element is added. You must insert January in position 1 of the array. This panel shows a confirmation that your insert was successful. You can then also add February in position 2 of the array. Hi, it's Gerard here from LearnDelphi. I'm a trainer in programming languages, and in this series, I help you to understand Delphi programming step by step and line by line. If this video is helpful to you, make sure you give it a thumbs up. And I also publish all the links I mention in this video in the description box below. In all our lessons, I start with the code immediately. I do not demonstrate how to create the graphical user interface. That is so that you only focus on the code of the lesson we are doing. If you want to follow what I'm doing but you want to save some time, you can download the starter project to start immediately where I start with this lesson. The starter and solution project files are available for download from my Patreon page at patreon.com/LearnDelphi. I also posted that link in the description. And I'm using Delphi Community Edition to demonstrate these lessons. There's also a link in the description if you want to download the free copy of Delphi. You can pause the video here and go do the downloads. While you wait for your download to finish, I will go ahead and explain the algorithm to insert new elements into an array. But let's first start with a story. The story is about the history of the Gregorian calendar and how it evolved into the calendar as we know it today. The first incarnation of our calendar was devised by the first Roman king Romulus in 735 BC. That calendar had only 10 months and only 304 days. Romulus named the 10 months as follows: Martus, after Mars, the Roman king of war. Aprilis, from the Latin word aperite, which means to open, as flowers open during this month. Maius, after Maia, the mother of Mercury. Junius, after the goddess Juno, queen of the gods. Quintilis, Sextilis, September, October, November, and December. From Quintilis to December, the names were simply derived from the Latin numbers 5 to 10. But this calendar was far too inaccurate when compared to a true solar year. So in around 700 BC, 2 extra months were added to the calendar by King Numa, and the total number of days were brought to 355. These new months were Januarius, after the two-faced god Janus, and Februarius, from Februa, which was a Roman purification festival. This new calendar still did not keep in step with the sun, causing problems for farmers. There were several attempts to put this right by adding extra months every few years, but they were largely unsuccessful and resulted in confusion. In 46 BC, Julius Caesar brought the calendar into line by adding extra days to the year and by tweaking the length of the months. The Roman Senate then renamed the 7th month from Quintilis to Julius in Julius Caesar's honor. After Caesar's death in 44 BC, the priest in charge of the calendar mistakenly began to add leap years every 3 years. This was corrected by Emperor Augustus in 8 BC. The Romans also honored Augustus by renaming the 8th month from Sextilis to Augustus. However, Augustus was jealous with his month having fewer days than Julius Caesar's, so August was changed to have 31 rather than 30 days. This was accounted for by taking a day from February, making it 28 days long, or 29 in a leap year. And that is how the months got their names as we know them today. By the 16th century, it had once again drifted away from the solar year. In the 1580s, Pope Gregory XIII reformed the calendar so that the century years were only leap years when divisible by 400. The Gregorian calendar we use today was named after Pope Gregory XIII. Now let's assume we go back in a time machine to the year 700 BC, just before King Numa inserted January and February into the calendar. The king orders us to develop a program to insert the 2 new months into position 1 and 2 of the calendar. You'll probably not understand our code, but we will explain it to him with only the first 4 months of his old calendar to keep it short and simple. We will have an array of 6 elements. This is a fixed size array, but you can also use a dynamic array. We use a fixed size array because we already know in advance how many elements it must contain. If you do have a situation where an array doesn't have a limit, you must rather use a dynamic array. In this explanation, we use the first 4 months of the old calendar. It starts at March and it ends with June. We know that we must add 2 more months at the beginning of the array, so we will end up with 6 elements. The last 2 elements will initially be placeholders for the 2 months that must be added. January must be added right at the beginning into position 1, where March is at the moment. You can't just squeeze it in because it will overwrite the first value and March will be lost. To get January into position 1, all the current elements must shift one position down. So June moves from position 4 to position 5, May moves from position 3 to 4, April from 2 to 3, and March from 1 to 2. Now you can insert January into position 1 where March was. You also want to insert February, but this time it must go into position 2. You can't put it directly into its position because you will overwrite March currently in position 2 and it will be lost. You will shift all the elements from position 2 one position down again. So June moves from position 5 to 6, May moves from 4 to 5, April from position 3 to 4, and March from 2 to 3. Now you can insert February into position 2 where March was. Now let's see how the algorithm looks. As mentioned before, our array has 6 elements. The last 2 are placeholders for the 2 months we must add. We will use a for loop to cycle through the array to move each element down from the position where the insert will occur. While looping through the array, we must store a few values in variables. An integer must store the number of the valid month names. The empty elements are not valid names, so the integer will initially be 4, and as we add more valid month names to the array, we will increase the number. It will also help us not to add more elements than the limit or the size of the array. We also need the string variable to store the name of the new month we want to insert. We will get this name from a user in a t-edit component. The user must also tell us in which position the new month must be inserted. We get it from a t-spin edit and the value will be assigned to the integer named int position. And another integer will keep count of the loop cycles. Now let's walk through the code. The integer that stores the number of the valid months must be declared under the implementation clause, because it must retain its value from one click to another. When the program starts, 4 will be assigned to it, because we start with 4 valid names. We won't count the 2 empty string elements that serve as placeholders. Then we assign the text provided by the user in the edit to the string variable named strNewMonth. Let's assume we get January. Next, we read the value in the spin edit and assign it to the integer named int position. Then the compiler enters the for loop. Here we use down 2 to loop in reverse from int valid months to int position. In other words, from 4 down to 1. Inside the loop, we shift June 1 index down by assigning June in index 4 of the array to index 4 plus 1, in other words index 5. Then we enter the loop again, and the loop count goes down from 4 to 3. Inside the loop, we shift May 1 index down by assigning May in index 3 of the array to index 4. Then we enter the loop again, and the loop count goes down from 3 to 2. Then we move April 1 index down by assigning April in index 2 of the array to index 3. The compiler enters the loop again, and the loop count goes down from 2 to 1. Inside the loop, we shift March 1 index down by assigning March in index 1 of the array to index 2. Now the first index contains a copy of March, so you can overwrite it with the new value by assigning the name in the string variable, which is January, to index 1 of the array. Finally, we increment the count for the valid month names to 5. Our code is now ready to insert another element, so let's also insert February into position 2. We assign the text provided by the user in the edit to the string variable named strNewMonth. It is February. Next, we read the value in the spin edit and assign it to the integer named int position. The user wants February in position 2. Then the compiler enters the for loop. Now we will loop from 5 down to 2. Inside the loop, we shift June 1 index down by assigning June in index 5 of the array to index 5 plus 1, in other words index 6. Then we enter the loop again, and the loop count goes down from 5 to 4. Inside the loop, we shift May 1 index down by assigning May in index 4 to index 5. Then we enter the loop again, and the loop count goes down from 4 to 3. Then we move April 1 index down by assigning April in index 3 to index 4. The compiler enters the loop again, and the loop goes down from 3 to 2. Inside the loop, we shift March 1 index down by assigning March in index 2 of the array to index 3. Now the second index, where the insert must take place, contains a copy of March, so you can overwrite it with the new value by assigning the name in the string variable, which is February, to index 2 of the array. Finally, we increment the count for the valid month names to 6. If this explanation was too fast, play the video again and slow it down. Then look at the code on the left and how every line affects the arrays and variables on the right. Now let's see how this can be done in a project. Here is my project in Delphi. Open the starter project that you downloaded and write the code with me. When the form is created in memory, we must display the 10 months that existed before the calendar was changed. We will program the form's onCreate event, so double-click a blank area on the surface of the form. Scroll up until you can see the implementation clause. To save time, I already declared the string array here. It is a fixed-length string with 12 elements. The array contains the English translation for the 10 months of the very first calendar from 735 BC that was devised by the Roman king Romulus. Although we only have 10 months, we declare the array with 12 elements. The last two elements are empty strings to serve as placeholders. You make an empty string with 2 inverted commas or single quotation marks with nothing in between. For an array that contains numbers, your placeholders can be zeros. I also declared an integer variable that keeps track of the valid month names, so it must exclude the 2 placeholders. And I assigned 10 to the integer, because the old calendar only had 10 months. Now go back to the form create event handler. Go above the begin statement. Type var. Enter and type strmonth as string. This string will store individual month names from the array that will be added to the list box. Go between begin and end. Type for strmonth in arr months do. Press enter and type begin. Enter again. Type this statement. We use a for in loop to extract each individual month name, and we add the names to the items of the list box. Run your program. The list box displays the 10 months in the array immediately when the form is created. The for in loop that we used will extract all the elements, not just the first 10. Remember, we have 12 elements. 2 of them are empty strings. If you click the list items under the last month, you will notice that the 2 empty strings are also loaded as list items. Close your form. Now we will program the onClick event of the button to insert the new month into the array. Click the Design tab. Double-click the Insert button. Go above Begin. Type var. Press Enter. Type strNewMonth, strmonth as string. strNewMonth stores the name that you type into the edit, and strmonth must extract each individual month name from the array so we can add it to the items of the list box. Press Enter, type int index, int position as integer. Int index must keep count of the cycles of the loop, and int position stores the value provided in the spin edit. Go between begin and end. Type 3 comments to separate input, processing, and output. You may also make these comments to-do items for a to-do list, like I demonstrated in the last video. Go under Input, type strNewMonth, =edtNewMonth.text. Here we read the text in the edit and assign it to the string variable called strNewMonth. Press Enter. Type int position, =sedPosition.value. Here we read the value from the spin edit and assign it to the integer called int position. Now go under Processing, type for int index, =int valid months, down to int position, do. Press Enter and type begin. Press Enter. Here you use a for loop that cycles down from the number in int valid months, which is 10 initially, to the number in int position. Now type this statement. We get the value in the current index and assign it to the next index. Here we use +1 to get the next index. This statement will shift the name in the current index down to the following index. Make a new line after the end of the loop. Type this statement. After the loop shifted each element a position down, we assigned a new month in the string variable to the index at int position. We now inserted a new name into the array, so we have an extra valid element at the specified position. Press Enter. Type this statement. Here we increment the integer that keeps count of the valid months. Let's display the output. Go under the output comment, type lstmonths.clear. As usual, we start with a blank list box. Press enter, type for strmonth in ARR months do. Press enter and type begin. Enter again. Type this statement. We use a for in loop to get each individual month name, and we add the name to the items of the list box. Run your program. Verify that the two placeholders are still listed under December. Type January in the edit. Leave the position on 1. Click the button. Now January is inserted in position 1 of the array and also displayed in the list box. Now select the placeholders below December. Notice you now only have one placeholder left. Type February in the edit. Change the position to 2 in the spin edit. Click the Insert button. February is now added in position 2. Now try to select the blank list item below December. There's no placeholders left. We still have a few things to do before King Romulus can use the program. One of the things we need to look at is avoiding errors. Let's see what happens if we try to add another element. Type anything in the edit. Select position 3. Click the Insert button. Now your program gives an error message. This is because you have a fixed length array that can only take 12 elements. If you try to add more than 12, you will get an error. You better fix that if you don't want to be lion food. Click the OK button on the error dialog window. Close your form. One of the best ways to avoid errors is to write defensive code. You do that by anticipating what can go wrong. Then you use conditional logic to trap the error before it happens. An easy way to avoid errors is to take away the user's ability to cause errors. You can do that by disabling components. Let me show you. Go on a blank line under the statement that increments int valid months. Type this if statement. Press enter and type begin. Press enter. Here we check if the valid month count is greater than or equal to the length of the array. If it is greater than, we want to take the user's ability away to add another element. So type btn insert dot enabled colon equals false. Press enter. Type edt new month dot enabled colon equals false. Enter again and type sed position dot enabled colon equals false. These three statements disable the insert button, the edit and the spin edit. We will have an else branch, so remove the semicolon after the end statement. Press enter and type else. Press enter and type begin. Press enter again. If the valid month count is not greater than or equal to the length of the array, the compiler must branch out to this else block. Now type edt new month dot text colon equals quote quote. If the user is allowed to add more items, we remove the text from the edit. Press enter and type edt new month dot set focus. We also set the focus on the edit so it is ready for the next input by the user. Run the program. Type January in the edit. Leave the spin edit on position 1. Click the button. Notice the text is removed from the edit and your insertion point is in the edit, ready for you to also add February. Now type February in the edit. Select position 2 in the spin edit. Click the button. February is added and your edit, spin edit and button are all disabled. So the user can't add another item. Let's also program the output for this panel. Close the form. Make a new line under the for loop that displays the elements of the array. Type this statement. Here we display a caption for the panel that will look like this. Run your program. Insert January and February into the array and verify that you now also see the confirmation in the panel. If you are happy, close your form and save your project. Next time we will learn how to insert new elements by their values in a sorted array. If you enjoyed this lesson, please leave a comment. And if you learned something new, please like, subscribe and share my lessons with your friends. Thank you for watching, and a special thank you to my supporters on patreon.com. And happy coding! See you next time.